Here in the I button and in description box below, you will get the complete playlist of numerical analysis. Welcome to video number 6 of numerical integration, where we are going to solve sixth problem based on this topic. This is also very important problem, and in this topic, that is numerical integration, we are solving total 8 problems, and all the 8 problems are equally important. So let us start with this sixth problem. The question says the following table gives the velocity v, this is velocity small v of a particle at time t. Okay, time is given as small t. Okay, and this is the table, that is at t equal to 0 seconds, velocity is 4 meters per second. Here you can see the time is given in seconds and velocity is in meters per second. So here we can say proper units are given in the problem. So here the time goes from 0 to 12 seconds. In the problem, it is asked, that is, find the distance moved by the particle in 12 seconds. We have to find the distance moved by the particle in which time, that is 12 seconds, and also the acceleration at t equals to 2 seconds. This part is very important, that is, we need to find the distance moved by the particle in 12 seconds. Okay. So first of all, we need to find the width, that is interval size. Here you can see the difference is 2. Okay, 0, 2, 4, 6, 8, 10, 12. Here you can see the difference is 2. But we have to show, that is width, which is given by small h, that is 2. But the formula is b minus a upon n. What is b? That is extreme limit, that is t equals to 12. What is a? That is initial value. Okay, so we can say b is 12, a equals to 0. So 12 minus 0 upon n. What is the value of n? Here you can see the number of elements given in the problem, that is 1, 2, 3, 4, 5, 6, 7. Here number of elements are 7. We need to subtract by 1, that is 7 minus 1 will give me number of steps. What is the number of elements? That is 7. We need to subtract with 1, so that we will get the number of steps, that is small n. So here number of steps is, number of elements are 7. So 7 minus 1, that is 6. So h equals to 12 upon 6, that is how much? 2. Okay. But here again you can see we need to find the distance moved by the particle in 12 seconds. Okay. We need to find the distance moved by the particle in 12 seconds. That means the time should start from 0. In problem number 3, if you see, in that problem, the value was not started from 0. So, for that problem, we considered initial time, that is 0. Okay, but here, the time is starting from 0. We are not considering anything. We will take the value that is given in the table. Since the value Since we need to find the distance moved by the particle in 12 seconds and the time starts from 0 to 12, so we'll consider this whole table. Okay, so let us start. We know that is v equals to ds upon dt. We are here to find the distance moved by the particle. So we can say ds equals to, we can take this dt to left hand side, that is v into dt. Now integrating both side. Okay, so this is going to be s, this is equals to v into dt, and here we are finding the distance moved by the particle in 12 seconds. That means the time goes from t equals to 0 seconds to 12 seconds. Okay, I hope this point is clear. The limit is from 0 to 12. Okay, fine. Now we need to understand which method to use so that we can find the distance, because in this problem also nothing is given like we need to use the trapezoidal rule or Simpson's 1/3 rule or 3 by 8 Simpson's rule, or we can say Weddell's rule. But if in the question it is asked by Weddell's rule, solve this problem, in that problem only we will use that rule. Otherwise we will try to go for Simpson's rule. Okay, we prefer Simpson's 1/3 if it is applied in that problem. So let us see whether Simpson's 1/3 is applied or not. Let us discuss in detail. we will not show the thing that I'm showing right now in the paper. Okay, you need not to show that in paper. So Simpson's 1 by third rule. For this method, the value of capital N is how much? 2. Okay, for Simpson's 1/3 rule, the value of capital N is how much? 2. Now we need to see whether the ratio, that is small n upon capital N, is a natural number or not. Okay, small n upon capital N should be a natural number. If it is natural number, then in this problem we will use Simpson's 1/3 rule. Okay, so here you can see small n upon capital N, that is 6 upon 2. How much? The value is 3. So we can say 3 is a natural number. So we can use Simpson's rule, Simpson's 1/3 rule in this particular problem. Okay, so we can write using Simpson's 1 by third rule. So we are finding here distance moved by the particle in 12 seconds. Okay, that is S equals to integration 0 to 12 v dt, and the formula for the Simpson's 1/3 rule is h upon 3 bracket open y naught plus. Okay, here again we need to see this is the value of y naught, this is y1, this is y2, y3, y4, y5, y6. So we are taking the extreme values here first, that is y naught plus y6. Close this bracket. Then 4 into odd subscripts of y, that is 1, y1, y3, y5, y1, y3 plus y5 plus remaining values, that is twice into even subscripts of y, that is y2, y4, y6. But here again we have used y6 dot, so we are not considering this. So we'll consider this 2 only, that is y2 and y4. So y2 plus y4. Now we are closing this bracket. Now in the next step we will put all the values, that is h equals to 2, okay, y naught, y1, y2, y3, y4 up to y6. We have all the values here. So on putting the values here, you will get distance, that is s equals to distance s equals to 552 meters. And this is my first part answer. Okay, here we are writing meter. Why? Because in the problem it is given, that is time is in seconds, velocity is in meter per seconds. So distance that we have calculated should be in meters. Okay, we have to write distance in meter. We have to use proper unit. Okay, now after completing the first part, we'll come to the next part, that is also the acceleration at t equals to 2 seconds. We need to find the acceleration at t equals to 2 seconds. For calculating this acceleration, we will take the help of Newton's law of motion. So here we can write, that is now acceleration at t equals to 2 seconds using Newton's law of motion, that is v equals to u plus a t. Okay, now we are taking t equals to 2 seconds. Here you can see at t equals to 2 seconds velocity is 6. So this will be final velocity and this will be the initial velocity. I repeat this once again. We need to find the acceleration at t equals to 2 seconds. That means this corresponding velocity will be my final velocity and this value will become the initial velocity. Okay, so here we can write, that is given initial velocity, that is v equals to 4 meters per second, final velocity, that is v equals to 6 meters per second, and time, that is 2 seconds. Okay, so putting the values here, v equals to 6, that is equals to 4 times a into 2. Now take this value here, that is 2a equals to, if we take this here, this will become 2, which implies a equals to, which implies a, that is acceleration, equals to 1, and the unit will be meter per second square. Okay, we have to know that is unit of acceleration, and that is 1 meter, sorry, and that is meters per second square. Okay, so this is the answer of second part. Okay, thank you so much.